In the audio physics lecture, today's topic is a spectrum and its type. Today we will discuss about the spectrum. When light coming from any object after passing through a slit is dispersed by a prism, we get a spectrum which is image of the slit for different wavelengths. A spectrum is divided into following types. First one is emission spectrum. When light emitted by a self-luminous object is dispersed by a prism to get the spectrum is called emission spectrum. Depending on the nature of source, it can be of following three types. First, continuous spectrum. It consists of continuously varying wavelength in a definite wavelength range. It is produced when solids or liquids are heated to incandescence and depends on their temperature only. In it there is no sharp boundary between two colors. For example, light from the sun or filament of an incandescent bulb, flame of a candle or carbon arc gives a spectrum of this type. Second is line spectra. It contains distinct bright lines and is produced by an excited source in atomic state. For example, a spectrum of excited helium, sodium vapors, mercury vapors, or atomic hydrogen is of this type. These lines are characteristics of the element are used for its identification. So, from line spectrum, we get the information of element. Now third is band spectrum. It consists of distinct bright band and it is produced by an excited source in molecular state. For example, molecular hydrogen H2, CO, NH3, etc. are of this type. That is a spectrum found from these molecules. In case of emission spectrum, here it must be noted that some sources give composite spectra, that is, one spectra superposed on the other simultaneously. Example, the spectrum of mercury fluorescent tube consists of a continuous emission spectra due to fluorescence, superposed by line emission spectra of mercury vapor present in the tube. It is also true for the X-ray spectra, which consist of a continuous emission spectra superposed by characteristics lines of the target element given by Moseley's law. There are three types of emission spectra. First one is continuous spectra, second one is line spectra, and third one is band spectra, which we have discussed. Now we should see the absorption spectra. First we see the definition. What is absorption spectra? When white light having all wavelengths of visible region is passed through a media and the transmitted light is dispersed by a prism, we get few dark lines or bands superposed on an otherwise bright continuous colored background. These dark lines or band depends on the nature of absorbing media and constitutes the so-called absorption spectra. If the observing media is in atomic states such as sodium vapor or argon gas, we get few distinct characteristic dark lines against colored background called line absorption spectra. However, if observing media is polyatomic such as H2CO2 or Kamenov solution, instead of dark lines, we get few characteristic dark bands against colored background called band absorption spectra. Now we see the Fraunhofer lines. The Fraunhofer lines can be cited as an example of line absorption spectra. These are dark lines observed in the continuous spectrum of the Sun and results due to absorption of light of certain wavelength in its atmosphere. Here we note that absorption spectra of substance is complementary to its emission spectra. Example, when excited, sodium gives two bright lines D1 and D2 in the yellow regions. So when white light is passed through sodium vapors and the transmitted light is dispersed, we will get two dark lines in the yellow region. Absorption spectra is explained with the help of Kirchhoff's law. That is, a good emitter is a good observer. So a substance in unexcited state will absorb those wavelengths which it emits in de-excitation. This is why the spectrum of Sun during total solar eclipse will be line emission spectra complementary to usual Sun spectrum. Now next, let's discuss ultraviolet and infrared spectra. Ultraviolet radiation. This region extends from 4000 angstrom to 100 angstrom in terms of wavelength. That is, lies between visible light and X-rays in the spectrum of electromagnetic wave. Although it is discovered accidentally by Ritter in investigating the relative effectiveness of light of different wavelength of visible region in blackening silver chloride. To his utter surprise, the observation disclosed that the effect does not stop at the violet end but is more marked beyond the violet. This in turn implied that there are certain invisible radiation beyond violet end of the spectrum. These radiation were named as ultraviolet. As the discovery itself suggests, Sun is a natural source of ultraviolet radiation. Carbon or iron arc hydrogen and helium discharge tube, mercury vapor lamp, etc. are commonly employed to produce these radiation. These radiations cause photoelectric effects photographic plate and exhibit the phenomenon of fluorescence. These radiations are studied with the help of quartz prism or a glass absorbs shorter wavelength of these. By converting ultraviolet light into visible light through fluorescence, a fluorescent tube gives more visible light than an ordinary bulb of same power. Also, due to its smaller wavelength, ultraviolet light gives better resolution in ultramicroscopic than visible light in optical microscope. These radiations are responsible for the formation of vitamin D in the skin and are also used for sterilization of drinking water. However, these radiations are very harmful for living being as these cause tan, sunburn, and snow blindness. Now we will discuss infrared radiation. This region extends from 7,000 angstrom to 1 millimeter, and we know that from 4,000 angstrom to 7,000 angstrom is visible light region. Now, the upper limit of visible light region, that is 7,000 angstrom to 1 millimeter region, is of infrared radiation, or we can say that it lies between visible light and microwaves in the spectrum of electromagnetic waves. Herschel accidentally found that these are certain invisible radiation presents ahead of red, which hits the blackened bulb thermometer. These radiations are called infrared or heat radiation and are present in the radiation emitted by all heated bodies such as sun, filament bulb, etc. In laboratory, glower are employed to produce the waves of this region. These are more penetrating than visible light. It also affects special photographic plates and can be used as photoelectric effect for photoelectric effect, and are used to see or photograph distant objects in dark. Longer infrared radiation cannot pass through glass, so are studied by rock salt prism. These radiations are detected by specially prepared photographic plates, thermocouple or radiometer etc. are used in wave therapy for the treatment of paralysis and sprains etc. Air-to-air guided missile follow the target by receiving infrared radiation coming from the target. So infrared radiation is also used in guided missiles, air-to-air guided missiles. So these are some a, a small view about a spectrum. Our next